Okay, we're back, and now we have all of the data that we need here in this right pane, and you can click on it to see how many of the different peaks that we have for a given mark, and again a little preview here. So now we want to know if we've got these three marks, K27 acetyl, K4 trimethylation, and K4 monomethylation. If we want to know where these things overlap and where they're exclusive, we need to start integrating that data. And there are tools to do that here within Galaxy. So what you can do is there are many different tools, and I encourage you to explore these and look at them. But a lot of what we'll be working with is within this tool set here called Operate on Genomic Intervals. And that's why we're using peak data, because this is genomic interval based data, chromosome start stop. So the first thing that we'll do is we're going to intersect K4 monomethylation and K27 acetylation. So what I mean by intersect, they illustrate it down here with a little bit of a description, is to say if you have one data set, in this case red, and a second data set, and you want to overlap these two, it will output the things that overlap. The thing that we're going to be doing more specifically is we're going to take this different parameter of this function to take just the overlapping pieces, and then that's going to give us K4 mono, K27 acetyl domains. So because your data is loaded up here, it's in interval format, it's within these drag down menus. So we're going to say return us the overlapping pieces of intervals of the K27 acetylation data that's intersecting K4 monomethylation. This is the minimum overlap in terms of base pairs that you need, so let's make it 150 to say that this approximates overlap of one nucleosome. So you can start this, and just like when we were getting the data, it will go over here and it will process it. So before it's done though, you can actually change the name, which I would recommend doing for all of your data sets so that you can go back and keep track of them better later. So we'll just call these K562, K4Me1, K27 acetylation domains. And it finished over here. You can save it, and it'll update. But now that we have the overlap here, and you can click on it and see that you have about 57,000 regions where you have overlap between these two marks. But what we want to know, if we're looking specifically for enhancers, are regions that do not overlap with K4 trimethylation. So in this case, to find out things that are exclusive, you can say subtract. In this case, we want to subtract trimethylation peaks from our domains that we just identified and return things where there's no overlap. So we're basically filtering out everything where you have K4 monomethylation. And we'll use this same single nucleosome. So once we've done that, we have that nice overlap subtracted with trimethylation. This is going to be a rough marker of K562 enhancers. This isn't perfect, but I think it's a good starting point to look at enhancers in this cell line. So now we have about 16,000 potential K562 enhancers, and we want to integrate the methylation data now to say which of these enhancers are methylated and which are not methylated, at least based on this type of measurement. So here we have a little under 500,000 different data points for methylation, and again it's just chromosome start stop for a CPG region, and then a methylation score here. So we want to find things that are above score of 200 and call those methylated, and then below 200 they're going to be unmethylated. So we can go back into these tools, and in this case we're going to go to filter and sort. So we can filter the methylation data, And we can use what they call regular expressions. And so by regular expressions, it means that you can put in some sort of text as long as it's delimited by or denoted by these two tick marks. And when it's saying here C1, we're talking about the different columns that you have. So in this case, this is C1, C2, C3, C4. And so we say we want, from our methylation data, column 4 that is greater than or equal to 200. And then this is going to be our methylated regions. So we'll just skip the header line that we have here. This is the header line that we're talking about. And we can get that going. While this is working, we can actually start to do another calculation while that's going on. And we can go back to our methylation data and say C4, in this case, less than 200. And we can get that going. In the meantime, I'm going to change this to be methylated regions. And it's already telling you a little bit about the information from how you generated this data. And if you ever want to go back within Galaxy to see the history of how these things were done, you can click on this little info button right here. And you can view the details about when it's created, how it was created, what was the filter, etc. So it's really nice to be able to track your backtrack on your data like that. So here we have unmethylated regions. And now we want to overlap our enhancers with our methylated and unmethylated regions to integrate those together. So we'll go back here into intersect. And we want to know of our enhancers, how many intersect with, in this case, methylated regions. And we won't use a full nucleosome, we'll just use one base pair based on the CpG dinucleotides being potentially smaller, and we will execute that. So from here, I'm going to sign off one more time and we'll pick it up for the third video once this data is done analyzing.